Hey, good morning. Uh, Today we are going to discuss about data structures using C. I am Dr. Veerana Kotgi. I am an assistant professor from Nitte Meenakshi Institute of Technology, Nitte deemed to be University. So here in this data structure using C, here we are going to discuss about many things. That is, first I will go for Unit 1. Before that, I will discuss the course overview. So here in this course, we are going to discuss about introduction to data structures and importance of data structures in problem solving and how we are going to implement the data structures using C, and more importantly we are going to focus on linear structures, non-linear structures, searching and sorting. So other than this, there are other things that we are going to discuss here is trees as well as graphs. So, so now I will move on to the next slide, that is course objectives. The basic objective of learning those course is the first objective is to understand the fundamentals of data structures. So that is why we are going to study this and how the data structure is there, and how to implement these data structures using C, and also to analyze the time and space complexity of the data structures that we are going to use, and also to apply the data structures that are there to solve the real world problems. So basically, so these are the main course objectives. So once we learn these course objectives, then we are going to learn what is this data structure is and how it is going to helpful for us to solve the real world problems. So now I will discuss here what is data structure is. The data structure is the thing but the way of organizing data efficiently. For example, so whatever data that is available, the first the data will be sparse or that data may be dispersed here and there. So when we go for searching a data that is required currently or that is needed, some and if it is not organized, then it is going to be very difficult to search the data. For example, if a dictionary would not be there, then how it would have been difficult to search a particular word. Since the dictionary is available and all the words are organized in a particular manner in the dictionary, that is why it will become easy for us to search a particular word from the dictionary. So, like that, the data structure is the data. There are many different types of data are available in real world. So, the most important thing is organizing data. If you don't organize the data, then it is going to be very difficult for us to find out the required data in the whether it may be a student details or whether it may be a medical related data or whether it may be a data with respect to education institution or anything you consider. Everything is data, and since everything has to be in a structured manner, have to find a way to arrange. We have to since they are not in a structured manner, we have to find a way to arrange it and organize it. So that is where this data structures will come into picture. So data structure, as I already said, it is a way of organizing data efficiently so that we can easily use that data. And here what happens is, then how to arrange this data. This data is nothing but information where we can store it in many different ways. So the different ways, in the sense here I am talking about, we can organize the data or store the data in the form of stacks, or in the form of queues, or in the form of trees, and or in the form of graphs. So these will help us to arrange the data in a particular manner, in the organized manner, so that whenever we need the data we can easily access it. So along with the stack and queues, we can also use linked list, where there will be, it is a node, linked list is the structure of the link is in such a way that it is like a node, where it is having three parts, where the middle part will be used to store the data or the values, and left part will point to the previous node, and the third part will point to the next node. So like that we are going to organize the data in the using data structures. So then what are the uses of this data structures? So this is very important. So we go for, as I said, we go for arranging the data or organize the data in using data structures. Then what, for what we are going to use it, that's very important. For example, it enables us to access the data easily. So as I have already said, the general example of a dictionary, the data is arranged in the, if it is arranged, since it is arranged in a dictionary in a particular structure, it is very easy for me to search any data or any word or the meaning of the word. So that is how it made us easy for to find the meaning of any of the word in a dictionary. The same way, the data is there. It is the data structures make the data to be accessed easily. For example, we have, since we are in the digital age, so every information has to be stored, because we can't, we don't use we don't use data anymore in the form of or we can't store data anywhere in the form of a physical law. Everything has gone digital, so digital data has to be arranged properly. So that is why when the data is used, and if I want to access it, and if I have stored that data by using a data structure, so that will make my it is very easy to access that data wherever it may be stored in the memory. So when I go, for example, it may be used for searching access, in the sense it may be for searching, or it may be for sorting the data, or it may be just for see the data whenever the data is required, or I may want to delete the data, or I may want to just go and read the data to get the knowledge. So that is why the easy access will be made by the data structure when I go for using this data. The same way it efficient modification. So whenever I want to make any modification into the existing data, or whenever I want to add the data, or I want to remove the data, as I said, I can easily modify it if it is stored using a data structure. Okay, like that, it will make for me to easy to access. And there are different types of data structures. Some are linear data structures, and some are non-linear data structures. Here, linear data structures, in the sense the data which is arranged sequentially. Non-linear means which is the data which is not stored in a particular sequence. The example for linear data structures are stacks, queues, linked list. Whereas example for nonlinear data structures are trees and graphs. So here in the as I said, the linear data structures are stacks, queues, and mm, this one, that is linked list. Here I am going to give a little bit information about what is a stack, what is queue, and what is linked list. So here basically a stack is one of the data structure which comes under linear data structures, and the stack is nothing but it is also a memory which is used to store the data, but data is stored in such a way that mm, it follows the method that is last in first out. The meaning of this last in first out is if I take a stack and push the data into the stack, so I can be able to access the data which which has inserted last. So the data which has been inserted first will go at the bottom, whereas the data inserted last will be at the top. So the first when I go for accessing this, I will access the data which is at the top first. Then I will go access the data which is above after the first one. Like that, I am going to access the data. So where we are going, there are many different applications where we are going to use this stack, and how it will be implemented using C, and how it will be helpful in different applications in the real world. So that we will see in the coming in the further mm, sessions. So in short, this is about this mm, mm, stack, and next is queues. Then what is queue? Again, as we see, queue is nothing but again it is also one of the data structures where the data will be stored or accessed in the form of first in first out. That means whatever data that has been inserted first, that will be accessed first, and the data which has been inserted last, that will be accessed last. That means here the data it is a little bit different from the stack in the sense. So as I said, in stack the first data will be inserted and that will be accessed last, but whereas in the queue the first data which is inserted will be accessed first only. So so if I here in a queue, it is like a queue where if you stand in a queue to buy a movie ticket, okay, what happens basically here is the first person who is in the line first, he will get the first movie ticket, the second person will get next, the third person will get next, and the last person in the queue get the ticket last. So like that, in this queue also, the data which is inserted first will be accessed first, and the data which has been inserted last will be accessed last. So this is about, in short, this is about queue data structure. And next, if I come to linked list, the linked list is nothing but it contains a nodes where, as I already said, it contains in a node structure is like a three different parts, whereas the left part will point to the previous node, the middle part contains the actual data or value, and the last part of the node will point to the next node. So here the data will be arranged Here again in this linked list, again there are two types of linked list. The one is a singly linked list and another one is a doubly linked list. Then what is singly linked list? Here in a singly linked list, the data will be stored, or we can, if I access the data, I can access the data in only one way, from left to right. I can insert it from left to right, or if I want to delete any node in the linked list, I have to first start from the left and then reach the node that I want to discuss, I mean delete. So that is how it happens. Okay, that is called as singly linked list. That means here I can't come reverse and do the insertion and deletion from right to left. So this is singly linked data structures. Then what is doubly linked data structures? So doubly linked data structures contains again the same node with the three parts. The only difference here is I can travel both sides, from left to right as well as from right to left. That means I can insert the data from left to right, from in between any node, or at the start of the node or at the end of the node. The same way from right to left I can insert, delete, and also I can access the data for reading purpose or whatever the reason for me to access it. So this is called as a doubly linked list. So this doubly linked list, so which one is better coming in these two? So it totally depends upon what type of application we are going to use. So depending on the applications, we choose whether to use single linked data structures or doubly linked data structures. Next is another type of data structures, that is non-linear data structure. So as I already said, non-linear data structures are trees and queues. So trees and graphs. So graph is nothing but it is um, it contains some nodes, which we call them as vertices, and there are some edges. So the set of vertices will be represented by capital V, and the set of edges will be represented by capital E. So the nodes are connected by the edges. So through those edges we can traverse from one node to another node. So if I insert data, so the node may be again in this trees, in this graph, there are many different structures. So that means in the form of connective connection, how they are connected. Depending upon that, there are many different types of graph structures are there. So it is, as why I will call it as non-linear is because I will not, if I have to insert any data or access any data, or delete any data from the graph, I will not follow the sequential path. Instead, I will go there and delete the data, depending upon where I want to insert it and where I want to access it or where I want to delete it. Also, it depends on where I actually want to access it, the way I want to access it. So this is how the graph will be arranged. So you know then where it will be used, graph will be used. So graph will be used in many different applications, many different connections of computers, uh, and many topologies, many different topologies. There we can use this. and also we can use many other different applications where I am going to discuss about them in the next this one session. So here I will stop for this now. In the next sessions we will see um, in detail about the different data structures.